And welcome back. Now today you can see on this workbench we have this little unit over here. That's a stepper motor. We have a stepper motor controller. We have another stepper motor controller. Guess what the theme of today's video is all about? But before we get onto that, there's a couple of other little items. I found this rather fascinating unit. I say fascinating, you think, well, it's just a 4-digit LED, isn't it? It is, but it's I2C controlled. And I've wanted an internal temperature sensor for my car for as long as I can remember. And I just didn't want one of those huge big fat things. And I didn't want an LCD display because you can't see it when it's dark. So this little unit is going to be built up into an internal temperature sensor for my car. So running on either 5 or 12 volts, I haven't quite decided yet. But connected to here, as you can see, with I2C connectors. So that's for a future project, and very dinky it is too. So I'll put that to one side. Now I mentioned there's this stepper motor. Now the stepper motor is a standard 28BYJ-48, and we can just have a very quick look on the web where I got it from. Here it is. And as you can see, it's extremely well priced, let's say. £1.90, which is probably about, what, $4, something like that. From the Far East, of course, that took a little while to get here, but it was both the board and this unit here. Now, I'd have in fact got this driver as well, which I haven't even tried out yet. And I'm hoping it's going to work in the same way because it's a lot smaller, as you can see, than this one. This one's great for testing. You can see all the lights running up and down. But I think for production use, or at least project finalisation use, this little one might be what I'm going to use. We'll see. Now, on this stepper motor here, let's just go back to the workbench. On this stepper motor, you can see that it's got a shaft here, which is nominally 5mm. That's across the broadest dimension. But as you can see, there are two flats on it. And, well, there goes one wheel. So what that means is that you can't just put a 5mm wheel or spigot or pulley or anything on there, because it just wouldn't really sit right. So what I've got is this ABS 3D printed wheel from my contacts over in Robot Maker. I'll give you the URL for that. Now, I know the chap who runs that, and he said, oh, I'll make you a wheel for that. So I've just simply got a quick thing off the internet. And this, with a bit of tweaking, I think this is the original without me tweaking it, and this is with me tweaking it. Basically, the hole in the middle wasn't quite big enough. Now, I wanted it a firm fit, but that wasn't going to go on at all as it stood. So I've made this one just that tiny little bit bigger. All it required was a minute of filing out, and that's going to fit directly on there. Now you might say, well, why on earth have you got a wheel, and what's it doing on this board? Well, we'll come on to that as part of the project in just a little while. And in fact, had I known how easy it was to print stuff in 3D, I'd have got him to print something like this. Now I'm in the middle of just shaping this, because this is actually going to be a pointer that I'm now going to have to mount on this wheel. It will look better than what it does now, but I could of course got him to make a pointer, think of a clock hand, with that hole in it, and it would have fitted directly onto here without any mucking about. So here we have a board. It's an A4 piece of board. It's a bit big for this camera at the moment, and the wheel's going to go on there, and that is going to go on the wheel. So if this is a pointer, that's a stepper motor. We know stepper motors move backwards and forwards. Any ideas yet? We'll see if you're right in just a second. Right, that's all for the intro. Let's move on now and start connecting this up. Here's the Uno clone DDC Arduino that I normally use. We'll connect it up to the stepper motor and run a simple little thing, and then talk about stepper motors in general, because there's a little bit more to them than perhaps I was first aware. So we'll do that next. So here we are back again at my workbench, and I've wired it up with the stepper motor driver, which is the standard one you get with this. In fact, on the web page we just looked at, it did say it comes with the ULN 2003 driver. That's the chip in there. So connected up to my Arduino. Now the only other thing is that the stepper motor itself requires a separate power supply. That's what plugged into here, and I've got that. If I can just move my camera around, you can see I've got this plugged into a separate 9-volt supply. That's just a 9-volt thing I've plugged into the wall, you know, for charging, I don't know, cameras or something up. So it is a separate supply. You can't possibly run this from your Arduino. Now the sketch that I've got going here is the simplest bit of code that I could find on the internet, and it uses the Axel stepper library, and there's a very, very good reason for using this, and we'll come on to that in just 1 second. This is the one here. I'll put a link to that in the code below. So here are the pins that we're using, the digital pins 3, 4, 5, 6. They get connected to the equivalent IN 1, 2, 3, 4 on here from the Arduino, and the actual stepper motor, as you can see, is a 5-wire stepper motor. Now that's actually important, and we'll come on to that in just a sec. Let's see it work though now. So if I plug this in, I've already loaded up the sketch that you see in front of you, so I'm going to plug that up in, and let me just switch back to the workbench so you get a good view. What's going to happen? Oh, well, first of all, the pointer's moving. So there we can see it's revolving. Let's move it round to there. Now watch these lights here. You can see they start to flicker towards the end, and they speed up again. Now this is one of the advantages of the Axel library, in that it starts slowly and ramps up to a maximum speed, because sometimes stepper motors can skip and jump when they first start off, because the torque obviously isn't available at those speeds. But by ramping it up, it does give you that sort of gentle start, and it will stop any of that stopping, jumping, skipping, whatever. Especially if you've got a heavy load on it, like a robot arm or even a wheel on a car, a robot car. If there's quite a bit of weight on the car itself, then it's better to start off small. Now I've set this sketch to simply turn roughly 180 degrees. I don't need that for what I'm intending to do with this project. But this does show you the nice gentle turning it does, and of course as the lights here slow down, look, oh, they slow down, then they speed up again. Now you can do all this from the sketch itself using the Axel stepper, as it shows you here. Look, it says what's the maximum speed you want me to turn, what's the acceleration you want me to do, and then you set the speed and you say move to. Now I've determined, purely by playing about really, that 1024 steps is about 180 degrees on here. It's not exact because I'm not really bothered at this stage. That can be determined a little bit later on. Now, what is it then about stepper motors compared to, say, servos, which I could have used for this project? In fact, let's talk about the project as a whole first, before we talk about stepper motors and servos. What is this project going to do? Let me take that off. Right, what I intend this board to be eventually, with this pointer on it, is a temperature display. So if you can imagine, this is going to be an arrow, like a giant clock hand or something. If you can see me above my video camera here, perhaps I'll just take me off. There we are. So this is going to be a pointer welded to this wheel, and it's going to show you the temperature of the outside temperature. Right, so it's going to be an external sensor put through a wall or through a window or something, and that's just going to move 90 degrees from, say, here, which might point to, I don't know, -5, to here, which might point to, say, 30. Certainly in the UK we wouldn't get a temperature range much beyond that, and if it does, it can just stop at that point. So I've got to shape this board eventually to make it into sort of a decorative shape. I don't know, might have a picture of a bird up here or something, but the scale will simply be from here to here. Now that's a pretty simple thing to do, but there's something about stepper motors and something about servos that is fundamentally different. Now what is that? To be quite honest, a stepper motor, as it shows you in this code here where it says move to, well, unlike a stepper motor where you can say go to the center position of your known travel, which in a servo is probably about 180 degrees. A stepper motor knows nothing about where it is. So for example, as you can see here, this is slowing down and stopping. Now if I disconnect the power at that point there, when I reconnect the power, that motor has absolutely no idea how far it's got. It will just move to the next 50 or 1024 steps that I told it to. It won't know how far it's got. A servo, on the other hand, has some built-in logic and mechanical identification of where it is, so it can always move to exactly the same place. Stepper motors won't. And if you've got it on a wheel, that's probably not a problem, because if that was now a car, a robot car moving along, it would start from wherever you put it down and it would just move n steps along. But for here, of course, being a temperature gauge, how do we know where the arrow is pointing? If we point this at, say, 20 degrees centigrade, or whatever that is in Fahrenheit, 66, something like that, and then the power is removed, when we reconnect the power, how does the stepper motor tell the Arduino, or the Arduino know by any means, that the pointer is already pointing to 20 degrees centigrade? Well, the fact of the matter is it doesn't know. So this pointer might have been left like that, but when this starts up it goes, well, I don't know where I am. So therefore, I don't know where to move my arm to tell you what the current temperature is. So we need some kind of feedback. And the way we're going to do that is with a little tiny switch. Now we could have used a Hall switch, so not magnetic. We could have used optoelectronics in some way. But what we're actually going to use is one of these. Let's move back to the workbench. Right. So this little tiny switch here, just get it in focus for you. There we are. So all it is a changeover, basically, as you can see there. Normally open is in the middle. Let me just get my pointer. Right, so the center is normally open, that's normally closed, that's always the common one. So what we can use is this switch arrangement. So as the wheel revolves, we'll put something on here so that it will close this switch at a particular point. That means the Arduino can then say, I've got to move the wheel until I hit this point, close the wheel. That will be my reference point. Then I know where to move to. Now, if we have a digital pin on the Arduino connected to the common on here and have the normally open connection, which is this one here, connected to ground, we can make the digital input pull up, so it saves us a resistor, input pull up on the Arduino, but when this switch is closed by the wheel, it will then bring it to ground and the Arduino can detect that. The question now, of course, is where do we connect this to? Originally I thought we might put it on the board at sort of this position and have the arm come down to touch it, but because of the arrangement of this wheel now, and I'm attaching this to it, that's going to miss. So it means either I put this on a block, put it perhaps through the board, but I think the cleanest method, given that I haven't pushed this wheel down yet because it's a very tight fit, I think having a little nub on the wheel itself, so some kind of little splodge of resin or something, it will come round and push on that wheel, on that switch. Imagine, so that's going to push on there and close it. So theoretically, this is all very straightforward, and as an introduction to stepper motors, I think it'll be great. It's the implementation of the hardware that just requires a little bit of thinking about. Now, I've just started, as you can see by drilling this out, to make this into some kind of pointer rather than just a flat piece of plastic. But I thought I'd better stop so you can see what it all looks like beforehand. But these stepper motors are used quite often for robot cars. So you can either make yourself a 3D wheel like this, and I've even got a video of that happening, so I can show you that in a sec. Or you can buy yourself some wheels, but they were fairly expensive. They were like £5 for 2 on eBay, and I thought that's just too much, too expensive. So I'm using this. Right, so the next bit I'm going to have to show you is, one, the pointer, well, shaped like a pointer for a start, mounted onto this wheel, and with this little switch somehow mounted on the board here so the wheel can close and open it. When that's done, we have our infrastructure in place. Then we get the fun bit of working with the Arduino code, and we can start changing this rather simplistic demo code here to something a little bit more exciting. In the meantime, have a look at the video of how this little 3D wheel was printed. See you in a bit. So this is the machine that actually made the wheel. I don't know how much this one particular costs, but it wasn't that cheap, I don't think. And here it is printing it. As you can see, it's going a bit mad there, filling in all the bits. Now this is being printed in white ABS. I asked him why ABS and not PLA, and he said because it's stronger and less problems with shrinkage as well. Maybe one day I'll get my own 3D printer and I'll be able to make a video of that. Okay, there it is, just coming to an end. Cool stuff. I think that's actually on my project now. That's not bad, is it? So please join me in part 2 of this when we look at how the project's transformed itself into this little tiny board with a nano and how it's actually displaying the real temperature now. Okay, it's quick, easy to do, and it's an enjoyable project. So see you in part 2. Thanks for watching. I hope you're finding these videos interesting and useful. You can leave comments down below and also click that little button that says subscribe. Okay, thanks for watching and see you in the next video.